I don't have any charts. I'm going to be fairly quick. I'll quickly introduce myself. My name is Behzad Raiszadeh. I got my BS in ME, Mechanical Engineering, from University of Virginia, and I got my MS from George Washington University in Aerospace Engineering. I've been here at NASA for 11 years, and I've worked on mostly Mars-related projects in here before joining the Office of Education here. I've worked with Juan and a number of people in this room. As I said already, I'm an engineer by training. I've spent most of my adult career being an engineer. I've spent most of that time doing model and simulation. In the past 11 years, as I've said, I've seen the most complex engineering problems being solved at NASA by NASA engineers. Some of the missions that a lot of engineers dream of working on. For example, some of the Mars missions. Since coming to the Office of Education, there is a common theme that I hear education type people talk about, and I'll illustrate. I've got a 12-year-old daughter that I help in math sometimes, and Wednesday night is my night. And poor thing, she always gets tons of math homework. We spent all afternoon working on her homework set. And sometimes she gets frustrated. And she says, why the hell do I have to do all this? It's stupid. And my answer to her is the same answer that I give to some of the people in this office that, they talk to me, they say, my students, that's one area they want to know relevance. What is the stuff that we are learning here? How is it related to engineering? Or how is it related to engineering science, that kind of stuff. And, as I've done some of my engineering work, I have reflected, when I solve something that is really, complicated, and after solving it, I kind of reflect on what fundamental concepts was in this problem that I just solved. And I always am able to go back and make a connection. What I learned in high school in my calculus class or my trigonometry class was what allowed me to solve this problem. And that's what I tell educators here, and that's what I told my daughter that day. And I said, what you're learning here is the foundations for what lets people land their spacecraft on Mars, which is, to me, a very complicated problem. I'm hoping as you guys move into the mentorship part of this program, that you'll stop your mentors and for a moment ask them, what are some of the fundamental concepts that are going into the simulation? Ask them questions, make sure you get to the bottom of some of the things you're seeing. And you will see some of the fundamentals in the kind of stuff we do. Juan mentioned F equal ma, force equal mass times acceleration. That is at the heart of a lot of the work that I've done, and we do here. This very fundamental concepts. So this is, like I said, my talk is short. We are closing. We are getting to the end of the opening ceremonies. I see that most of the mentors are here, minus one, I believe. Jeff Robinson, I don't see, but everybody else is here. So, you have an opportunity to stretch your legs, meet your mentors, and then come back in a little while. One more announcement I wanted to make. I wanted to make you aware that there is a stipend, $2,500 stipend for the best lesson developed at the end of the program. So Cecilia, Karen, are there any logistics I need to announce? Yeah, the question is,
Thank you, Behzad.
have the slides been distributed to the teachers? And the answer is yes on the thumb drives. Is that?
We're double checking to ensure that they're on the thumb drive. If they're not, we will ensure that before, at the earliest possible opportunity, we'll get those distributed out to everyone.
Okay, so we'll check on that and we'll get back to the other centers. So with that, that's the end of the opening ceremonies.